The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to the webinar. We'll start in just a few moments from now. Thank you. Okay, just about another 2 minutes from now, we'll start the webinar. Hello, everyone, and welcome to our webinar. This again will be on Simultaneous 5-axis in SolidCAM, and this is part 3 of our webinar series. Again, given by Ahmad Ankar, our expert in this field. But before we start the webinar, I'd like to remind everybody that we have our SolidCAM World coming up towards the end of May, and we'd like everyone to register. We have a full schedule ahead of us. To register, all you have to do is go into our website and log in, and when you go to the reseller area of our of our website, you can just go ahead and click to register, and that's all you have to do to do that. You have all the information as far as for travel information, the agenda, click to register. All of that is over here. We have a full schedule, and there will be something there for everybody. So please register as soon as we can so that we can get all our numbers correct. Okay, I will now turn this over to Ahmad. So Ahmad, I will make you now the presenter, and you can unmute yourself, show your screen, and get started. Enjoy the webinar, everybody.
Thank you. Thank you very much, Sydney. Hello, everyone, and we're going to be back again with our webinar today on Simultaneous 5-axis. Today, we are going to cover about 5 topics, okay? And to inform you, we're going to have 2 more sessions of Simultaneous 5-axis in the next 2 weeks, and then we are going to move our focus onto HSM, a similar kind of an approach even for HSM. Today, we are going to focus ourselves on another tilting mechanism that we have inside SolidCAM, and that's using the lines. We're going to see a couple of methods, the sub-methods of tilting lines that are there. And then we are going to focus ourselves on gouge check, how to avoid gouges using the gouge check methods, and also how to machine the part using a gouge check. Okay, there are 2 items here. We are also going to see the third topic, which is basically the priority when you apply gouge check. I have seen in many users, they apply the gouge check like they feel it's necessary, but actually you need to have your priority. You need to put the right one first, the second one next, and third one, and so on. If you jumble in that, then you get wrong results. So you need to understand the priority. We're also going to touch on a very small but very important topic called area roughing in our roughing and more area. and also focus ourselves on the surface quality, achieving good surface quality. Okay, so let's start with this particular part here I have where I would like to machine this fillet, and the method that I'm going to use is chilled through lines. Okay, so I'll add some 5x operation, and I'll use morph between two curves, and in the geometry already have the geometry picked up. So that's the faces that I'm going to use, and the starting edge curve is the topmost curve, and the end edge curve is the contour one. So I have the geometry defined, and I would like to start and end at the exact surface edges. In the tool, I have defined a taper ball nose, and this is how the taper ball nose looks like. So I have a taper ball nose defined with a corner radius, tip radius of R2. I'm going to leave all these defaults except here. I'll just make it as 0.5, a zigzag, and in the tool axis control, we are going to define using lines. Okay, so here I have defined my lines. So I'll pick the contour. Now I'm going to actually make a definition because it's very important to understand the direction of these lines. When you're using lines method, you must be careful about the direction. Selecting here and giving a direction down will give you wrong results. Okay, so if you have a direction that's going downward, it's better you reverse it to make it upwards, because that's my vector, that's the direction of my tool axis. So that's my first line. The second line is over here. Again, the direction you can see is going from bottom to top. Third line is here, and this is my last one. Okay, you can have as many number of lines as you want. Remember that more number of lines will mean that the tool will always start gradually shifting from the line 1 to line 2, line 2 to line 3. So if you have more lines, you'll always see the tool dancing because it's trying to shift its tool axis from one line to the other line, trying to maintain it. So the best possible way is to provide as limited lines as possible so that it gets a much bigger area to change its tool axis direction from one line to the other. So, and it's much more smoother. Okay, then we come to the subtype, which basically is asking us how do you would like to use these lines. So the first option is all lines are weighted by the distance. That means all lines will be considered on their proximity to their distance to the surface that we have used. Okay, so we have now defined 4 lines. So it's obvious for this surface, for let's say most part of the surface, it's going to consider line 1, and the next part it is going to consider line 2, and on this surface maybe half of it will consider line 1 and the other one will be line 2. So it will start from line 1 and gradually tilt towards line 2 and so on. Okay, so this is the most easiest of it. In my link, I will just increase the sidestep percentage and let's hit calculate. Okay, so first of all, we have so many retracts. Okay, you can see that we have some issues here. There's an unconnected pass out here, and this probably could be the fact that we could not find, or SolidCAM could not find the right edge, because I have asked SolidCAM to start from the exact surface edge here. Okay, so when you are doing this, and even though you feel that your model or your part is extremely good, there could be small variations, and because of that, we could have problems in SolidCAM detecting continuous cuts. So I will add a start margin of 0.1. Okay, and that sorts the issue of not finding the cuts. Okay, let's look at how the tool axis looks like. Let's switch off the holder and let's take the start. Okay, so that's my first point. You can see that if I go from this side here, this is my first line. So you can see the tool axis is now parallel to the first line. Okay, so that's how it has started off. Now, as it moves forward, as it moves forward, it tries to interpolate from this line to the next possible line. Okay, so now you can see at this point, the tool axis is parallel to the second line. And when it moves next to the other point, it's actually now becoming parallel, or the tool axis is becoming parallel to the next line that it is finding up. Okay, and as it traverses forward, it will focus itself on making the tool axis parallel to the last line out here. Okay, so basically when you use the first option, it will consider all the lines that you have provided. It will check the proximity to the surface and try to align the tool axis to that nearest line on that particular to that particular point. Okay, now the next option out here, when I use it, by the way, in this current scenario, if I go to my tool axis control, closest to the surface on and all lines weighted by the distance will give you the same result, because I have 4 lines and all of them are lying on the edge of the surface. So it will actually pick each of the lines like I picked for the first option, all lines weighted by distance. The second one, however, is more interesting. It's like using the closest 2 lines. It will try to find the normal distance between the surface, the furthermost point on the surface to the line, and try to see which lines are the closest to the surface and use those 2 lines to determine the orientation of the tool. Okay, so here I have a snap distance, which is basically the distance from the furthermost point on the surface to the line. Okay, that normal distance. I have set it as 0.5, so it will now try to find any lines which are there in 0.5 distance. Okay, so let's hit the save and calculate button. I immediately get an error. It says that it could not find any tilt lines using the snap distance of 0.5. Why it could not find? Let's check. So let's minimize this and let's go here. So in evaluate and measure, I'll pick this point and this line. You can see that this distance is 7.46. So obviously it could not find this line. Let's check the next one, this point and this line. Sorry, this point and this line. This is 5.23. Obviously 0.5, that's the reason it could not find even the second line. Let's pick this line, this point. This is 5.45, and this line point and this line, this is 9.95. So it's clear that 0.5 distance could not find any lines in the vicinity. Okay, so what we are going to do is I will change it. So I have 2 lines that are in the vicinity of 5 millimeters, 5.23 and 5.45. So I will say find lines which are within 5.5 millimeter distance. Let's calculate. You can see that at 5.5, it found these 2 lines. So now what it is going to do is it's going to keep the tool orientation not with this line, but with this line, the second line here. So it's going to now come all the way from the starting point till this point here with the tool axis that is parallel to this line. Okay, you can see that it's parallel to that line, and from here it will now shift its tool axis and go parallel to the next line, because it finds the nearest 2 possible lines within the snap distance. Okay, so at this point here, I will see that the line is parallel, or the axis is parallel to the second line, and it will hold on to this axis all the way till the end. All this line and this line are ignored because they don't fit into the snap distance. They don't fit into the distance that is defining it to be close to the surface. Okay, so I hope this is clear, because this is pretty important. Sometimes we just give 0.5 and it doesn't do anything. Then we change it to 1 millimeter. Also, it doesn't do anything. So in that time, you need to measure from the furthermost point on the surface to the line. What is the distance that you're getting? And that distance is what you're going to use as your snap distance value. Okay. Another thing that we notice here is basically our retracts. You can see that it's just pulling out in one direction and then going up straight. Sometimes this could be problematic because it could just scrape the surface out here, especially if the tool is a bit large. So we will also change the way the tool retracts in this particular case. So I'll go to levels, and instead of asking it to go in X, Y, Z in a particular direction, I will use a user-defined direction and define 2 points. One point here and the other point here. Okay, and I will use the retract distance as 75, entry safety distance 10, exit safety distance also 10, and let's calculate. You can see that now the tool is pulling out in that direction. The vector used is in that direction. Okay, you can see that it pulls out to safety and then moves up. So next time you get a part and you would like to pull the tool out in the normal or in the vector direction, then use this method and not the simple plane method or the cylinder method. You could also define 2 points. These are really safe approaches. Okay, so it's better than using a simple plane, right? So in our tool axis, we have now covered most of the items, what we did last time and what I showed you today also using lines. Let's move to another very important subject of gouge check. Now, in gouge check, like I said, you have two functionalities. One is actually avoiding collisions, and two is using those avoided collisions to machine actually a surface. Okay, it's a tricky thing, but it's a very, very important and a useful feature. Okay, so let me open a part. Okay, let's open the port. Let's open the port. Okay, so I have this part here, and I would like to machine these surfaces. Okay, this is basically a port, but the internal surfaces look like a hexagon. Okay, so we are going to machine these surfaces. As usual, I would like to use morph between two curves. And in the drive surface, I think I have the surface here. Okay, so these are my drive surfaces. And my starting edge is basically, let's pick contour 6. And my end is contour 7. Okay. And we're going to limit ourselves by 2 points. And I'll just put these 2 points at -1 and -90. Okay, 2 points. That means I'm just going to go down to 90 millimeters, and I'll pick tool number 4, a lollipop tool. Levels, fine. Take 2 millimeter depth of cut. In the tool axis control, I'm going to use again through curve, and in our curve, I'll say start to end, and my tilt angle, a tilt curve is basically this one. This short curve. Now here again, like I mentioned last time, the direction is very important. Don't go from bottom to top, but go from top to bottom in this case. Let's accept this. Okay, and let's hit save and calculate. Okay, so I have basically the tool path, and you can see that very soon that it's a mess. Okay, it doesn't look good in any sense. Why? Mainly because the curvature here is smaller than the tool curvature or the tool radius. Okay, this is R12 and I'm using an R16 tool. So what I can simply do now is to see if this is resolved further, can go to toolpath parameters and put a round corner with 1R radius and see if we can fix this problem. Okay. We are actually creating more mess, but however, you can see that it still doesn't really fix the problem. Now, you could have encountered such issues many times where the actual surface geometry produces really bad results, and you somehow have to cut the geometry. So today we are going to use a trick. It's actually not a bad trick, but it's a legitimate trick inside SolidCAM. And here we use the gouge check to actually give us a much better result. So what I've done here is around that same surfaces, okay, let me hide this. I have created another tube, simple round tube, okay? It's just wrapping around itself maybe about a millimeter more than the actual surfaces. So it's slightly outside the actual surfaces. So what I will do now is I'll add or just modify this itself. So I'll edit. And in the geometry, I'll pick this tube surface. Just check the direction. For a change, the direction should be pointing inside and not outside for us because we would like to machine the inside. Okay. And the start edge curve in this case would be this one. The upper curve and the bottom curve is also here, that one. Okay. Everything else remains the same here. So let's run and check the calculation. By the way, we'll just disable our round corners. We don't need it for such a simple geometry. Let's calculate. Okay. It's done. And I'm getting a pretty neat one, but let's change some parameters to remove this retracts. And in the sorting, I'm going to give it spiral option. Okay, that looks better now. So I created a pretty smooth looking toolpath, but it's only machining this round tube. But my focus or my goal is not the round tube, but it should machine this particular surfaces. So what I will simply do now is I will use gouge check. And I'll tell SolidCAM to check against the tooltip. Check surfaces, which are basically these. It has to check against these. And when it finds the gouge, it should retract the tool. Now, where should it retract the tool? We have an option in a sub option. When you click on retract tool, we have a sub option where it can retract along to cut center. That means if I draw a circle on this, the tool will start moving towards the center point till the time that it doesn't find any gouge. Okay, so it's almost like you're projecting the tool path back onto these hexagon surfaces. So let's calculate this tool path. Okay, this is done. And you can see that I'm now getting a much clean tool path coming on my hexagon surface. Okay, so if I just run the simulation, you can see that it will run pretty smoothly. You can see that it's actually following the cylinder, but machining the hexagon surfaces inside. So you can actually machine any geometry which you feel that it's bad or it's extremely difficult to control your tool axis. You can create a much simpler surface, machine that simple surface, and just project this tool path using the gouge check onto those complex surfaces, where the tool axis will always be pointing towards that simple surface and actually be machining those complex surfaces. So we are going to see another part using the retract tool function, and that's going to be slightly different. Okay, let's go check and let's open this file. Okay, no. Just a moment. Okay, so now I would like to machine all of these surfaces at, let's say, a 15-degree tilt. But if you look, all these surfaces, they're pretty difficult to keep a constant tilt of 15 degrees to my z-axis. So what I'm going to do here is I'll create a Sim5x operation, and you can look at the surface that I've created. It's much big. So my drive surface is going to be the surface below. Okay, let's check the direction. It's pointing downwards, so let's reverse it to point upwards. Okay, and I'll pick the tool. So it's a 8 bullnose. Sorry, that's not the tool. Let's add a new bullnose tool here. 10 bullnose. Okay. Levels, everything is fine. Toolpath parameters, would like to take a 2 millimeter step over. And in the tool axis control, I want a 15-degree tilt to the main axis direction. Okay, that's it. Let's save and calculate. Oops, sorry. Morph between two curves. Let's see if I already have. I don't have it. So create a new curve. Nope. Okay, that's the first curve. Then comes the next curve. Let's switch off the tangent propagation. Okay, that's the second curve. Let's calculate. Okay, so I have this toolpath out here. We have a wrong retract, so we need to fix the retract. Let's go to the levels, plane height. Let's pick a point here. So that's 73, so I would like 100. Okay, 10 and 10. Let's calculate. So I have now fixed it. So I have the toolpath below here. So if you run the simulation, it's actually going to be cutting through the part here. Okay, so it's tilted to 15 degrees, and that's how I want it. Now I would like to use the same toolpath but cut only this area. Okay, so in that case, I switch on my gouge check, and I enable the gouge check with the 3 because I have the short tool with the tooltip, short tool shaft. So I'll switch on the arbor, and in the check surfaces, I'll just pick this color, find the face. I don't want this face, but I want to add this face also to it. So one, this one, this one, this one, and this one. Okay, so that's done. And I will say retract the tool along the tool axis. That means I've tilted the tool at 15 degrees. So it's going to pull the tool back out at the tool axis, which is tilted at 15 degrees, till a point that it doesn't find any more gouges on the surfaces that I selected as my check surface. Okay, so let's save and calculate this toolpath. It's running the collision check. Perfect. What you can see now here is that it's actually machining it, and as it comes close to the surface, it's now retracting the tool on the surface now, because those are the surfaces that I asked to be checked for gouges. But I have got several areas that are actually not needed for me, okay? Because it's sheer waste of time that the tool goes down all the way down, takes a step over and comes up. So I want to remove all those areas. To remove all those areas, all you have to do is go into the advanced option in the gouge check method, and you will switch on the drop tool down wherever needed. So it's going to drop the tool wherever it's needed. But my second condition is remove the areas where the tool drop fails. Okay, so it's obvious that here the tool drop is not going to be of any use because the tool drop will stop exactly where the check surfaces are. Beyond the check surfaces, there is no more tool drop. So I'm going to remove all those areas where the tool drop is not succeeding or it's failing. Let me calculate this tool path. So even though you have got a much bigger drive surface and a smaller area of check surfaces, you can use this method to trim off the tool path that is not essential or it's going to be a sheer waste of time. Okay, so what you can see here is it just removed those areas where the drop tool is going to fail. So it just comes up till the time the contact point is here and goes back again. So all those areas that were unnecessary can now be chopped off just using this function to remove those tool drop areas. Okay, perfect. Let's move to another part, another area of gouge check, and that is basically trim and relink. So let's look at another method of trim and relink. So what I have here, let me switch off all these operations. Let's suppress this. I've created a simple HSS. Now it could be the HSS or it could be 5-axis, so that doesn't actually matter because the gouge check works exactly similar. So I would like to, I have machined this and then I have got some check areas where I would like to check for collisions between the surface and the tool. So I'll copy this operation and I'll paste it below here. And I'll switch on my gouge check. So my first gouge check is for tool shaft and tool tip. And we are going to trim and relink the tool path. So I'm going to trim. And what should it trim? My first option is just trim the areas that are colliding and just relink them. And only the check surfaces need to be checked. So these are the check surfaces that the software needs to check, SolidCAM needs to check. And let's hit save and calculate. So what now it has done is it has come up to the place where it finds collision, it trims those areas and relinks it to the next portion. Okay. Now, obviously, you could ask what are the other options here. So then you have got an option where you can say trim the tool path after it finds the first collision. So if I run this calculation, you can see that the moment it finds the first collision, it keeps trimming till it finds no more collision on the first point. So that much a portion of the tool path is just deleted, and it just continues forward. This area again, there is no collision. You can see that here there's a collision, and on this part also there's a collision. So it has just removed these two areas. So wherever the very first collision starts, it removes that area till it finds no more collision. The other option is to trim the tool path before the last collision. So you're going to have slightly different tool path here. Okay. My last collision is happening here because the first collision has happened here. So last collision has happened here. So it's now going to remove all the tool path from this side. And similarly, the first collision is here, the last collision is here. So everything behind it is gone till it finds no more collisions. The other option is to trim the tool path between the first and the last collision. Okay, so you can see that most of the areas now will disappear. It will look as if we have made the trim collisions only, except you have got this region where it finds the first collision and the last collision and just chops off that area. Because here it's finding both the collisions, whereas here it's only finding either the first one or the last one. So I'm asking it, between the first and last, remove the toolpath. Another option is before the first collision. Before it finds the first collision, it needs to chop the toolpath off. So it found the collision, removed everything behind it, okay, before the first one. Similarly here, removed it, because this is my start point, okay? My start point is not from here, but from here. So the moment it comes to the first collision, it'll remove everything. Now, where are you going to use this? Well, it has got its own uh, uses, but most of the times you're only going to use the trim collisions because you just want to remove the areas that it is colliding. You do not want to project it back onto the check surface and create number of cuts, which will do nothing. But you can use always this method where it can just chop off the areas that are colliding against the check surface. Okay, let's open another part and look at another check options. No. So I have this part here, and let's calculate this without the gouge check. So if I run the calculation, this is how my calculation looks like. So it's actually going to machine it in that way. And if it finds a collision, okay, right now we have switched off the collision, so it's going through the part. So let me change. Tool looks a bit odd. Let's change the tool. 12. Okay, that's good. So let's go to the collision and enable the tool collision with the arbor tool shaft on the tooltip. And the option here is stop the toolpath calculation. Now, when I say stop the toolpath calculation, it doesn't mean that nothing will be displayed. The moment it finds the very first gouge, the calculation will be stopped, and whatever toolpath was calculated will be linked and presented to the user. So you can see that only a portion of this toolpath will be calculated and not the entire thing, because the moment it finds the very first collision, it will stop the toolpath calculation. So you can see that the next pass would have collided. So it has stopped the toolpath calculation and only given the user the areas where collision does not exist. Furthermore, even if the collisions are not going to happen, like for in this area, the collisions won't happen. It will not give you the toolpath because it's already stopped its calculation much before. Okay. Another part, and let's look at the contact line. Nope. Right. So I have a part that looks something like this, protruding the surface out, and I would like to machine the surface that I just selected. So what I have here is, let's switch off the gouge check in the very first instance. So let's switch off the gouge check, and the tool I'm using is basically a taper tool. So I'm using a taper mill, which has an angle of 10 degrees on the side. So let me run with the tool axis control at 90. So my taper tool will now be aligned, or the 10-degree face will now be aligned to the surface that I'm cutting. And let me hit the save and calculate button. So you can see that it's now machined everything, and now I'll switch on the gouge check. Now, what is a gouge check here? The gouge check, the first one is to just ensure that it doesn't cut this part by the angle. The angle should not, the tool should tilt and avoid if there's any collision. So we are not much bothered about the side tilt, but we are more bothered about this one here. So we are going to enable the second gouge, which asks the tool to be retracted along the tool contact line. Now, what is a tool contact line here? Let's go to Paint. and the tool was something like this, because it's a taper ball nose, a taper tool. Okay, something like this. Although this should have been aligned, but that's okay. The tool contact line in this case is not going to be this one, but the tool contact line will be this line, or the taper line, with the 10-degree line, and the tool will retract itself out in that way. Okay, tool won't retract in this way, but tool will retract along the tool contact line. So if I switch on the tool contact line and calculate this tool path, you can see that the retract is now happening through the tool contact line, or the 10-degree line. Okay. Now, if I change this tool to a simple ball nose tool, okay, which does not have the angle, and I have a ball nose, you will see that immediately the tool contact line will become straight. It will become like the surface. And let me calculate the tool path, and you can see that the tool contact line is now straight. It's just retracting straight. So the tool contact line, retract along tool contact line, will pull the tool out along the side face angle. If the side face is straight, it'll just pull it straight. If the side face has an angle like a taper mill, it will pull along the taper. Okay, it will pull the tool along the taper so that no more collisions happen. Okay, let's look at another very interesting area that I'd like to show you. Sorry, let's open the impeller. Okay, so what I have here is I have these two vane blades here, and I would like now to machine the area. We saw that we could do that by providing morph between two surfaces, giving a curve to tilt, and then generate the passes in between. Okay, what we are going to do today is slightly different. We're going to look at another function, very nice function, and the application of this function is pretty wide, and it's not limited only to impellers, but it could be used in several applications where you have got a space to be machined, a space to be roughed out, and you like a much better tool path. Okay, so what we are going to do now is we are going to add some 5x operation, and we will use the parallel to surface function. In the geometry, in the drive surface, I would like to pick 1, 2, 3, and 1, 2, and 3. So I just pick a pair of those surfaces, and the edge surface here is this one, this one, this one. Okay, unlike a multi-blade, I just have to be sure about my selection. And I will say determined by number of cuts, it's just 1. Let's pick the tool. I'll pick 8 ball nose. And let's go to the levels, tool axis control, 90. Okay, and in the gouge check, okay. Now here, I'm going to explain you two functions. The first and the second gouge check, how to determine which goes first and which goes second. The first gouge check in this case should always be the tilt, because if you say check the bottom first and then check the tilt, so it will check first the bottom, ensure that there is no gouge, and then it will try to come here to tilt the tool. The moment the tool is tilted, there is all possibility that the tool can again gouge at the bottom surface, and it's not going to check the surface again because it's already past that phase. So in our case, whenever you encounter a situation where you need to put more than one gouge check, then the priority of putting the gouge check becomes very important. So the first one is always the tilt. Allow the tool to tilt and gouge into the surface below, and then switch on the gouge check, push the tool along the tool axis away from the surface below. Okay, so that you first clear the drive surfaces using tilt, and then clear the check surface using the retract along tool axis. First one is tilt, and the second one is retract along tool axis. So that's the priority. That's how you need to put the gouge check. So let's enable, and here it's going to be tilt only with the drive surface, side tilt, And the second one, I just want to check with the tooltip, the check surfaces. And what are my check surfaces? It's basically 1, 2, 3, and that's it. And maybe this one. Okay. So I have got a single pass. Let's calculate. Okay, so what I have here is I just get two nice passes, which look something like this. I'm making sure that I don't get any collisions on the side. Okay, I don't have any collisions with the bottom, and it has cleared the blades nicely. So I just get one pass on either side. Okay, and once I have this pass, which basically tells me that I have an area, because I've got two blades, it's machined both the blades and now understands the area between these two blades. I can go to roughing and more and switch on area roughing. Okay, well, switch on area roughing. What it asks me basically is my rotary axis, which is the fourth axis, is basically Z. So it's going to rotate around Z, not swivel, but rotate around Z. My step over in this case is going to be about 2 millimeters. And I will use the zigzag method and switch off the trim cuts. And the area roughing calculation will be applied after it has done the collision check of the blades, those two collision checks, the tilt tool and retract. Once this has been done, only then it will apply the area roughing. Okay, and let's say okay and hit the calculate button. Okay, this can be fixed by going into links, say 300 or even 500. Calculate. Okay, so what we get is a beautiful floor finishing tool path just by selecting those two blades and the bottom surface and ensuring that there was no collision here. I have created a very nice looking bottom tool path. Okay, you can see that it does a neat path and it'll make sure that it doesn't collide because we already have checked for the collision between these two blades already when we created the single pass, right? So now if I want to create a roughing pattern for this particular area here, it's very simple for me. Okay, I simply again edit the toolpath, and instead of using determine by number of cuts, I will start maybe avoid exact edges and provide the maximum step over as 2 millimeters. So I will get a very neat looking roughing path just by using the area roughing. So the application here doesn't just stop at impellers. You could think of a channel running all over your part. You could use that as your part. You could do the roughing, or just you would like to do a finishing of that, you could do the finishing of it. If you go to the SolidCAM website, you can see a part that was that's there, which basically talks about a channel on a rectangular part with some holes on it, and it's been carved with a radius. That particular channel is a classic example of applying area roughing. So it doesn't actually just say impellers. You can use it. You can use it on the parts that are displayed on our website also. Okay, so you have a nice roughing toolpath here already. Okay, similar to what we create with multi-blade. All right. So we saw both the methods here. First of all, the gout check priority, which one comes first, which one comes second. And the next one was our area roughing. Another very important topic that I'm going to touch upon today is the surface quality. Okay, and this is a very important topic for people who have issues with the quality of surface when they cut. Okay, so what I'm going to do here is I'll edit this HSS because it's basically the same Sim5X and HSS. And I'm going to just calculate morph between two curves and the surface below. And I have the toolpath. Let me take it into machine simulation. Okay, so it's in the machine simulation. And you can see the distribution of points out here. Now, it's not very clear what happens with this point distribution, but if I take it slightly away, okay, if I zoom it, unzoom it out, you can see a nice region out here which looks completely different from the other portion. Okay, now this is happening because the point distribution in this area is not proper. Okay, now if it was HSM, we have another way of handling that, but in HSS, it's actually very neat and clean the way we handle such issues with surface quality. It's pretty clear in machine simulation that this area is actually going to give us a much different surface quality than the other areas because it has got much lower density of points on the surface. To fix this, what I'm going to do is I'll edit toolpath and I'll switch on the distance factor. I'll not say 15, I'll just say 10 because it's very important to see how the points end up. Because if I give it too close, it'll be like a dense area of points, nothing will be visible. So I've kept it at 10 millimeter. So what SolidCAM has done is it's now put points at 10 millimeters each, even in this region. But what is also happening, you can see that if I zoom out, the problem of this area still remains because in other portion 10 millimeters, in this 10 millimeters is different because this area is more or less flat or having a very high degree of curvature. So I still don't fix this problem even after putting up the distance between 2 points or controlling the distance. To fix that area, in spite of having a distance, switch on the synchronized points. What synchronized points will do is, if my first point is appearing, let's say here, or second point is appearing here, then the second point on the next pass will also appear close to this area here and not somewhere else. Okay, so it will try and get them in one single line. All those points of the second point, it will try and get them in one line so that the finish will look much more uniform when it goes onto the machine. So let me save and calculate this. Let's go to the machine simulation. Okay, you can see that that portion, that area now disappeared completely, which now says that you're going to get much better surface quality than you would have got by using just distance or without using the distance. We had a major pink kind of a patch here, which was looking really bad. Now, SolidCAM has synchronized the points in such a way that it's getting equal number of points on each of these toolpaths, and the same pattern is replicated on the subsequent passes of the toolpath. So it's very important that whenever you use the distance function, please use the synchronize points button to get the points synchronized on every pass of the toolpath. Okay, so basically today we are going to end it here. In my next webinar, next Thursday, we are going to look at another very important topic. Okay, I'm just going to show you that. Let's open some part because I just want to show you the GUI. I'm going to touch on a very important topic. Many people have asked what it does, how it works, and what actually happens on the machine. And that is basically the pole control. Okay, we are going to delve more into the pole handling of the software. What is a pole, and what is the reaction when it encounters a pole situation? All this will be explained to you in my next webinar, that is on next Thursday, and we'll also see some application-based machining strategies like multi-blade during the next webinar. I'm done for today. If you have any questions, please ask me questions.
Okay, Ahmad, thank you very, very much for the webinar. Always looking forward to them. And as you said, we'll be meeting again next week for your next webinar. So I'd like to tell everyone, remind everyone again about registering for SolidCAM World at the end of May on our website. So register as soon as you can. And we'll see you again at our next webinar. Take care, everyone, and have a great weekend.
Thank you. Bye-bye.
Bye-bye.